Assalamualaikum warahmatullahi wabarakatuh and good morning to lecturer Encik Wan Muhammad Wardi. My name is Syah Zarib bin Abu Bakar and our group 2 is want to present about lab report of Servo motor. Okay, we go to the objective. For the objective of this experiment is to determine the gain G1 and the time constant T of the servo motor transfer function with differing initial loads. As you can see with the procedure, there has the G1 and the time at the servo motor. Next is the additional theory. A servo motor is made up from DC and AC power of potential gears and a control circuit. To begin, gear assemblies are used to reduce the rotational speed of a gear by increasing the motor torque. Assuming the static or initial condition position of the servo motor shaft inside is not generating about electrical signals, the output of the potentiometer is exposed. There are two distinct signals, one from the potentiometer and the other from another source. The output data will now be processed by a feedback system and an error signal will be output. Incoming incorrect signal provide motor input and the motor begins to rotate.
Salam sejahtera. Kumpulan kami akan buat eksperimen servo motor system iaitu response for calculating and measurement. So yang ni dia punya apparatus, and then dia ada power supply, dia ada signal generator dengan continuometer punya switch which dia connected dengan internal load dengan gearbox. So first one kita akan buat saya akan explain dulu tentang apparatus. Dekat sini dia akan tunjukkan RPM and then yang ni adalah signal untuk voltage display. Apabila kita tambahkan voltage dekat continuometer, dia akan tambah dengan voltage display and then juga RPM akan increase. Di mana first kita akan buat disengage punya, di mana voltage akan meningkatkan internal load punya RPM. So first one kita akan gunakan positive drive motor, di mana dia akan tambah daripada 1 voltage hingga 9 voltage. So kita akan guna continuometer voltage, kita akan tambahkan sehingga dia jadi 1 volt. So selepas dia capai 1 volt, kita akan ambil reading dekat RPM. Lepas ambil reading dekat RPM, kita akan tukar dia punya speed kepada drive motor, and then kita ambil reading dekat voltage meter. So, yang circuit pertama dia akan fungsi kepada internal load, di mana dia akan memusingkan dia dalam internal load. So, kita akan buat step by step daripada 1 voltage hingga 9 voltage for the first internal load. So, for the second volt, kita akan tukar balik yang ni kepada speed, and then kita akan increase dia capai 2 volt. So, kita akan repeat sampai 9 volt. Lepas kita finish for positive and negative for the disengage, kita akan jadikan voltage dia diusung balik. And then kita akan jadikan sistem ini engage. And then kita akan on dead zone size. Kerana eksperimen 2 dia akan guna gearbox dengan dead zone size di mana daripada 2 hingga 10. So kita akan gunakan positive dead zone and negative dead zone. So first kita akan eksperimen buat tentang positive dead zone. So step dia sama je. Selepas kita tukar dia punya engage, kita akan tambah volt again. Untuk dead zone dia punya size 2, kita akan tambah 1 volt. Di mana lepas kita tambah 1 volt, kita boleh nampak gearbox dengan shaft mula berpusing. Sebelum ni dia tak pusing untuk disengage. For engage kita akan guna yang ni. At the same time internal load pun dia akan pusing. So kita akan ambil reading untuk positif. Setiap dead zone dia akan increase dari 2 ke 3, and then voltage dia akan increase dari 1 ke 2.
Okay, we move to the observation of the experiment. It's focused on observing the sensor output and voltage change. The flywheel moves clockwise, and the reading speed sensor output will be taken to the data. The motor drive input characteristics are recorded and gain characteristics are analyzed to determine the linearity or non-linearity. The steady state of G is calculated by measuring the slope.
So the result of the experiment is gained from plotting the graph using the result we obtained from the experiment. Result we obtained, the first one is using disengaged motor drive voltage to find out speed sensor output voltage. So it shows linear positive and linear negative graph, and the differences between the linearity is lower. While for the engaged clutch, the motor drive voltage against speed sensor output shows linear positive and linear negative graph, but there's a difference between positive and negative in the speed motor output. Thank you.
Okay, move to the discussion. First, comment on the shape of the motor drive voltage to speed sensor output voltage characteristic. Alright, so depending on the type of the motor drive being used, the form of the motor drive voltage is to speed sensor output voltage characteristic change. Pulse width modulation technique are used in motor drive to change the frequency and voltage sent to the motor. The motor drive regulate the motor input to enable speed and torque control. Discuss why time constant for various inertial load increase as the size of the load increase. The time constant is the property of a first order linear time invariant LTI system that characterize its reaction to a step input in physics and engineering. Time constant is the number of seconds it takes for the current flowing through a capacitive circuit to reach 36.7% of its starting value. Its numerical value is equal to the circuit product of resistance and capacitance. Improve this experiment. Improving the number of variables under control, enhancing measurement method, boosting randomization to lessen sample bias, blinding the experiment, and including control of placebo group are a few approaches to increase the validity of an experiment.
So in conclusion, to sum up everything that has been stated so far, we can conclude that the objectives of this experiment was achieved, which is to determine the gain G1 and time constant T of the servo motor transfer function with differing inertial loads. To recap, servo trainer comprises of a motor-driven rotating shaft, upon which is mounted having an inertial load flywheel, tachometer to measure shaft speed, electrically driven motor that provides power to rotate the shaft, electrically operated clutch to enable the power driven shaft to be connected to a secondary shaft that is positioned, output shaft which connects to a 30:1 ratio reduction gearbox, and output shaft position sensor. DC or AC current, potentiometer, gears, and control circuit are assembled, made up a servo motor.